You might remember I was there at the panel session, and the previous session I made a technical topic about the software measurement, but in this talk they're completely different actually. So I'd like to talk about the software quality management capability or cultural issues or the key driver in IoT era. But the main point is, so I would like to introduce some practices we tried, or anyway, so what you have learned from our history to achieve the software. Sorry. Anyway, so I'd like to mainly focus on software quality management. Okay, so let me talk about the very recent. Let me check the connection. Let me try again. Sorry. Maybe it's okay. Thank you. Okay. A few days on July 30, so Japan have launched a rocket, not a missile anyway, so, rocket. So, and this is a very first trial for launching a rocket by a private company. So we have a governmental organization called JAXA. They launch rockets. They've been launching rockets, but this is the very first time to launch a rocket by a private company. But unfortunately, it failed within maybe 60 seconds or something like that. But the founder of Mr. Horie, the investor of Horie, by facing with failure, he mentioned, we were able to get valuable data and we'll succeed next time. It's a very good comment. So actually, so our history of total quality management, we have learned a lot from our failure. So this is very important to achieve a higher quality or reliable software. So, and first I would like to talk about, I'm sorry, the color problem. So, I would like to talk about how to make use of failure experience to share it among the organizations. So, when we try to make use of failure experience, such kind of rocket failure, so we need to share the knowledge among the organization members, but how to write down our knowledge, okay? So, for example, this is a manual, so the manual says you need to do this, and go along this way. So we sometimes share our experience, or failure experience as a knowledge to describe this kind of manual, but unfortunately it's difficult to share our experience, okay? Then, because there's no description about what and where energies are. So most of the manual write only the way how to do that, but there's no description about what and where energies are. So, and there's the other type, another type, so don't do type description. So there are energies, but it's not so useful for us to make use of our failure experience. And also another type, so failure cases, only failure cases are written in the document. So if you do this, then you fail. If you do this, then you fail. So this is a failure cases document, but based on these two types of documents, so we cannot make use of our failure experience. But to make use of a failure experience among our organizations, so at least we need to describe the how and why did you fail. And also, how can you avoid the energies? So with this kind of information, we can transfer our knowledge or experience, especially for failure experience, to others among the organizations based on our failure experience. So this kind of practice is actually very important to share our knowledge. So sometimes, when we consider about the test documents or the failure reports, so sometimes you write down just here's the energy, or when we use these test cases, then we fail. But to share our knowledge, so how to write down our experience is actually important. So by accumulating these activities, I'm sorry for the coloring problems. Anyway, so by accumulating these activities, we can prevent some problems in advance. So we usually call it prevention acts. So prevention acts, as well as other practices such as Kaizen, continuous improvement, or factor control, managed by data, or some other practices. So these are the elements of total quality management. So the goal of the total quality management is customer satisfaction. So the customer satisfaction by providing quality products and services. And the core of code of conducts include, for example, customer first, plan, do, check, act, and prevention acts, and so on. So you might know what TQM are, but I would like to briefly introduce the history of TQM, Total Quality Management. First, we have learned a lot from outside of Japan, from Deming, Schuhart, or Juran in 1950s. So, and then we divide the ideas we have learned Anyway, so we devise the imported ideas and to make use of the ideas for our Japanese specific needs. Then it was formulated as a total quality management. So some ideas such as Ishikawa diagram or QC circle, Kaizen, total quality management are well known outside of Japan in 1980s. So I'm sorry, the color. So maybe you have ever watched the film Back to the Future 3. So it's a very interesting conversation here. So Doc in 1955 and talks to Marty from 1985 about a broken IC. So Doc mentioned, no wonder this circuit failed. It says made in Japan. Okay, this is the 1955. Okay, made in Japan means worse and cheap and worse at that moment. But Marty from 1985, he mentioned, what do you mean, Doc? All the best stuff is made in Japan. Unbelievable. So during these 30 years, the situation or the level of quality is dramatically changed in Japan. So what happened? Just as I mentioned before, so we have incorporated a lot of ideas from outside and we devise to the ideas to make use of the ideas. And very specific practices such as how to write down the failure knowledge. Okay, so just writing energy, it's not useful, but how and why and how you can avoid the energies. So with writing this kind of information, so we can make use of our experiences. Okay, thank you. And by doing these activities, so we can create new knowledge and we can share our knowledge and we can create new knowledge among organizations. Have you ever heard SECI model, SECI model? Have you ever heard? Thank you very much. Nobody? Okay, thank you. Anyway, so this model was proposed by Nonaka and Takeuchi in 1995. Actually, I'm also Nonaka, but the different person, okay? Still alive, okay? So, and they carefully watched the Japanese organizations and what process was there to share the knowledge and to create a new knowledge. So then they modeled the process. The very beginning, so each individual has some their own, his or her own tacit knowledge, but it's tacit because of the so it's difficult to transfer his or her own tacit knowledge to others. But by communicating each other, so individually, so the one person's tacit knowledge can be transferred to the others. So they call this phase a socialization phase. And next, so individual tacit knowledge will be expressed in the explicit knowledge. For example, in previous slides, so I mentioned how to write down the document or manual or how to express our failure knowledge. So by doing this kind of activities, so we can share our knowledge within a small group, some individual group. So within a small group, we can share our knowledge. Then those groups are collected. Then we have an organization. So then, so we can form a more systematic and totally systematic knowledge, explicit knowledge. So by this phase, so they call combination phase. And after that, so internalization phase appears. So based on the systematic explicit knowledge, we can understand, oh, we need to do that, or we never do that. So based on our previous failure experience, so based on that, we totally understand the systematic explicit knowledge. But once we completely internalize the systematic explicit knowledge, individual can create their own new tacit knowledge. Then, by following these cycles, the new knowledge is creating. So, Nonaka and Takeuchi called this process a SECI model. And actually, so this is a very well known among the business administratives in 1990s or 2000s. So I think so this process is still useful for the current IoT era, okay? Because so knowledge of failure experience, it has a very valuable knowledge. So you can only obtain the knowledge by developing IoT devices or some application domain. They can fail, they might fail, but they can get knowledge. So it's a valuable information. And the knowledge of failure experience is so somewhat rare. So the other person cannot get this kind of knowledge. And inimitable resource. So the other, especially for it was still in the tacit knowledge, so the other person cannot imitate or copy the information. So the knowledge of failure experiences is at least 3 characteristics: valuable, rare, and inimitable resources. And in addition, by utilizing the knowledge among organization, Then, so we can make use of the failure knowledge among organization. As I introduced myself, so I'm a member of business faculty, business administration. In the area of competitive advantage, or there's a theory named resource-based view theory. And one of the key idea is VRIO framework. VRIO stands for variable, rare, and inimitable, and the organization utilization. So with these characteristics, so the resource brings the company or organization a competitive advantage. So this is a VRIO framework of resource-based view theory. So that's why the failure experience, just I mentioned in the very first slide, so we failed. But failure, we can learn a lot. And to make use of the failure, we need to express our tacit knowledge to explicitly, to the explicit knowledge, and make use of the knowledge within the organization. It's a very useful thing. And this is the main issue I want to say this speech. And of course, so, knowledge sharing and the creation among organizations is getting more important in IoT era in terms of competitiveness. Okay. So now you might know, you well known about IoT, but here's a research paper written by Michael Porter. He's a very famous strategist, and Porter and Hepperman wrote down how smart connected products are transforming competition. So you can see the original paper by Googling their names. So anyway, so capability of smart connected IoT products has some features about monitoring, control, and optimization, and autonomy. Okay. Then, when we facing with the IoT era, so five forces will have some impact on our competition of our industry. So Porter represents the competitiveness, five forces of competition in 1980. So there are five factors which affect on the competition of an industry. The first one is rivalry among existing competitors. The second one is threats of new entrant, and third one threats of substitute products or services, and the bargaining power of suppliers and buyers. So by using this framework, we can see what happens in our industry, even though the IoT era. So according to Porter and Hepperman, so sorry, let me check. Okay, so about the rivalry among existing competitors. So they mentioned smart connected products have the potential to shift rivalry, opening up numerous new avenues for differentiation and value-added services. So, which means IoT increases external complexity of products and services, and then increasing their competitive advantage against existing competitors. Let me introduce an example by using Comotrax's example. Do you know Comotrax? No, thank you very much. So, do you know Komatsu? Komatsu? Okay, thank you. Actually, so in Japan, it's a very major case to describe about IoT. So in 2012, around 2000, Komatsu launched a new service called Komotrax, which so almost 20 years ago. So each machine has a GPS antenna and a communication antenna and a lot of controllers and a lot of devices to monitor the engine status or oil temperature or amount of gasoline, etc. So by connecting every machine to the internet, so users can see so where each machine is. So actually the headquarters of Komatsu is located in Akasaka, Roppongi, and they can see all of the machines, and they can from the Roppongi, and they can see the current status of each machine. So is it working or not, or is it moving or not, or how many gasoline they have, so and so on. So actually, so this feature, originally, this feature was developed not to avoid thieves. So sometimes, some operators ride on the machine and go away and break ATM machine. So this was a problem. So, but by adding these features, Komotrax enabled users to perform preventive maintenance. And then, so preventive maintenance means, so by monitoring the machine's status, temperature, oil temperature, and the engine status, or running time, and so on. So they can predict the when and where will be have some problems in the near future. Before that, so service staff of Komatsu visit to the user's site and change some parts or ask the users to send their machine to the maintenance site. So by using this, so they can maximize the operation time of each machine. But then these features cancels Caterpillar's advantage, 20 years ago's advantage of their worldwide dealer network. So at that time, so Caterpillar constructed a very huge dealer network, and it's very suitable for breakdown maintenance, which means, so if a machine breaks within 24 hours, so service staff of Caterpillar visit to the machine's place and watch what happened and change the parts and so on. But Komotrax canceled the Caterpillar's advantages. So it happened in 20 years ago. So and here is a chart about Komatsu versus Caterpillar. And the solid line is for Komatsu, and the dotted line is for Caterpillar. And the two lines on the bottom side, so which represents the operating profit ratio, which means how much operating profit earned against to the sales amount. Okay, in 2001, Komatsu's operating profit ratio was almost zero. But by introducing Komotrax, they drastically improved their profits. And also they reduces a lot of costs, such as selling, general, and administrative expense. So around 2006, so there's almost no difference between Komatsu and Caterpillar. And so Komotrax introduced, by introducing Komotrax, Komatsu's financial status has drastically improved. And now, so Komatsu has a Dantotsu solution. So now, so there's no operator on the dump truck. So no operator dump truck running on the loading site and hauling load. So by using a fleet control. So this is the very main feature, and I just mentioned before. So by introducing smartness and connectivity to the current product, so it will change the rivalry among existing competitors. So Komatsu changed the rivalry against Caterpillar. Okay, so this happens in Komatsu. Sorry. Okay, so and maybe so you might know the case of GE. So they has almost the same features to maintain the jet engines or electricity plants or medical equipment in advance to the breakdown. Okay, so increasing external. So now, so we see each product, the complexity of each product is increasing, and by increasing the external complexity, it has a competitiveness. And also, GE make use of this IoT resource to maximize utilization. So they make use of the same facilities or features for every domain, so such as jet engines, electricity plants, and the medical equipments. So by making use of the IoT resource, so they can effectively use the same IoT resources. So this is what happens in our industry. Okay, so what happens in our software industries? So now maybe you might face with difficulty, but this kind of change introduces us that more smart software are required, more connectable software or system are required, more function, more reliable, and more maintainable software are required. So we need to face with these requirements change that brings from the complexity of the products. And also, the IoT brings some changes about the threats of new entrants, and also the threats of substitutes products or services. According to Porter and Hepperman, so the upper left side, so new entrants would face significant new obstacles, starting with a high fixed cost of more complex product design, embedded software technology, and multiple layers of the new IT infrastructures. So when we talk about the Komatsu's example, so maybe so there's very low threats, but there the new entrants come to the Komatsu's rival or Komatsu's domain or Komatsu Caterpillar domain. So because now just we mentioned before, so now the Komatsu's machine has autonomy, and it's completely difficult to compete with this kind of a complex system for the new entrant. So that's why a new entrant would face significant new obstacles and a more complex product design. So it's very difficult for new entrants to enter this market. But however, barriers to entry will go down with smart connected products. For example, so I'd like to express another example about Mobike in China. This cycle with IoT features. So you the bicycle with GPS and communication unit. And user can find the closest bicycle at your place with his or her smartphone. This is a sample screenshot. And the user can return the bicycle after using at several areas. So there's a wide area prepared to rent or get it back to the place. But previously, so China introduced public rental cycle services. So at that moment, so user can pay the fee with IC card, and the user needed to go to a certain place to rent and return the bicycle. But Mobike's connectivity changed the competitiveness drastically. So the connectivity of Mobike cancels the usefulness of existing service, in this case, public rental cycles. So this is a threat of new entrant. So barriers to entry go down with smart connected products. So in summary, so higher level of external complexity of products and service with connected features can be a barrier against new entrants and substitutes, but with connectivity or with good services, so it will be a substitute of the current services or products. So, and this is a very well-known tool, at least in Japan, to describe the quality attributes. So we usually mention the must be quality and attractive quality. So by drawing two axes, the horizontal axis represents not achieved or fully achieved of a very specific feature, and the y-axis represents customer satisfaction. So, for example, so by adding some features and by achieving the features, and user might satisfy with the feature, then we call it one-dimensional qualities. It's relatively easy to pursue the customer satisfaction by achieving the attributes. The purpose is to fulfill the attributes, then the customer will be satisfied. But the very important attributes is attractive qualities. So, for example, in this case, most users do not unsatisfied with the public rental cycles. Oh, it's very useful because there's no connected rental cycles so far. But when we faced with the Mobike, so it's so useful. We noticed the usefulness of the Mobike. So these kind of quality attributes we call attractive qualities. So the blue line represents, so when it does not achieve specific quality attributes, in that case, connectivity, user don't care. But once it was introduced, so it's very tightly connected to the customer satisfaction. Okay? And also, the other one is must be quality. So this kind of quality attributes is somewhat difficult to manage, but it doesn't contribute to customer satisfaction, increasing customer satisfaction, but it affects to the customer dissatisfaction. For example, so now I'm really facing with customer dissatisfaction with the connectivity of the laptop to the projector. So most of you think about, so it happens again. So these features is, I think, so it's a must be qualities. So now I'm so dissatisfied because the duration of the anyway, so we think about the connectivity between the laptop and the monitors, so it must be fulfilled. But we usually don't care. It must be quality. So by connecting normally, but we don't satisfied with that. But facing with this situation, we like this. Sorry, we totally dissatisfied. So this is must be quality. So the important thing is we need to pursue the new attractive quality. So when the new attractive quality features were appeared, the previous attractive quality will change to the one-dimensional or must be quality. So the user satisfaction and attractive quality is tightly connected. The IoT brings this kind of new features about attractive quality. And also, let's think about the bargaining power of buyers and or suppliers. So, smart connected products dramatically expand opportunities for product differentiation, moving competition away from price alone. So, just I introduced Komatsu's example. So, and actually, so Komatsu's Komotrack service is free for the every users, but they can sell a high price range of the product based on the Komotrack's features. And compared to with ownership models, product as a service business model can increase buyer's power by reducing the cost of switching to a new manufacturer. So Potter and Hyperman mentioned. And when we see about the bargaining power of suppliers, smart connected products often introduce powerful new suppliers than manufacturers have never needed before. And also, new suppliers may also gain greater leverage given their relationship with the end users and access to product usage data. So in summarize, so if you want to read the whole full text, please see the original paper. But to summarize, so real value of the products and services for users should be redefined. For example, in this case, so a public rental cycle was very useful for most users, but now the core value has shifted to the connectivity. So it happens most of their products. So now then we think about what is the real core value for the users. So as I mentioned before, quality first is one of the core code of conducts in the total quality management. So we need to focus on what brings customer satisfaction, or what is the real value of the product and services, even though you are connected, you are related to the product or service with the testing phases, but you should ask what is the core value of the product compared to the threats of new entrant, or threats of substitutes, products or services, or bargaining power of suppliers, or bargaining power of buyers. So by thinking about these kind of topics, so I believe it must be useful for test analysis or building a test strategy. And also the relationships among suppliers should be redefined. Which means, so I would like to explain one example about the suppliers relationship. Actually, so this is not the IoT, but I would like to express about the open source software example. So now, a lot of products or service to develop or to release some kind of products or services we highly rely on the open source software. But so sometimes we just get some components from the open source repository and put it into our products and test with a lot of aspects. Then we assure the quality of the product. Then we release the product to the market. But now there's a big bargaining power of the open source community. So they have the they control when the version will be the next version will be released with the open source software, and how to change the open source software. So, but for example, so the Hitachi, the developer, so they need to follow the new version or the strategy of the open source software. If they incorporate the open source software, then so this case Hitachi provided their core competitiveness of the software component to the open source. Usually, typically, so they do not want to open their core resources or core algorithms or core software to the outside, but they put their core assets to the open source community, and the developers actively collaborate with the open source community. Then they got a lot of information and a lot of softwares, and they actively communicate with the open source communities. So by changing the relationship between the supplier, in this case open source community, they increase the reliability and of their products with a lower cost. So we need to rethink about or redefine the relationship between the suppliers. So this kind of thing happens in the IoT era, especially for IoT era. And also, with the feature of IoT, so product usage data is a new bargaining power of suppliers. For example, GE, maybe you know well about that. So GE's jet engine has a lot of with a lot of sensors, so they got a lot of data. And I've heard that so from Tokyo to New York, so more than 5 gigabytes of data are collected during one flight. Just I've heard that. I didn't evaluate the information. But anyway, so a lot of data are collected from only one side flight, and the airplane company can make use of the data, and the GE also can make use of the data. So this kind of data has a power to the market or to the competitors or the existing relationship between the supplier and the producers. Then, so now we are facing with big data and intelligence systems. So now, so we have a lot of learning algorithms, and such as random forest method or deep learning, or a lot of algorithms are usable now. So but usually we do not need to develop existing learning algorithms by our own hands, but we can select or from the open source community, or we can just select some implemented algorithms with using some tools. So we do not need to. We do not need to implement the learning algorithms by ourselves. And also, data strategy and building a learning model are the keys to make use of the data. And then, so we need to incorporate evaluation process of a learning model. So it will be a key for to make use of data in software or system or software development process. So, so the importance of data strategy and the importance of learning model and the importance of data collection and feedback cycle, it's very important when we try to make use of data. Then, so developing a program, the importance of developing a program is relatively smaller. So now the program development will be, and the testing of the program will be a group of the total systems. So the point is, so that in the IoT era, data has a very powerful tool to differentiate your product or your services. But then, so how to evaluate the learning model, how to evaluate the data, or how to evaluate, so which learning models should be incorporated into your system. So this kind of activities will be more important. So we think about the total software or system development process in the viewpoint of the data strategy or making use of data. Anyway, so this is a summary of my talk. So I'm really sorry for the display problem. So increasing external complexity is unavoidable in IoT era, but it brings your product or service as a sustainability or competitive advantage in your market. So then we need for more smart, connectable, and function and reliable software. We need to face with these high requirements. And the smartness of the product and the connectivity changes the core values. So think deeply about real values of IoT products at the customer site. So as I mentioned in my first part of my talk, customer first is a heart of total quality management. Okay? So smartness and the connectivity changes real core values. Will change the core values for the customers. So we need to think about the customer first. What is that? What should we do to pursue the customer first? So, but by doing these experiences, so experiences obtained through IoT product development is a major source of valuable knowledge for us. So this is a rare and valuable and inimitable resources. So knowledge sharing and creation is a key to success. And just I mentioned in the Seki model in the previous slides. So how to share our knowledge, experiences obtained from our experience of IoT product development. So how to make use of the knowledge or experience is a key to success, I believe. And also, please consider the environmental factors of competition. So I introduced with 5 force model, threats of new entrants and substitutes, bargaining power of suppliers and buyers. So these factors affect our competition, and also which in turn affects the core value of the customers. So I repeatedly mentioned customer first is a heart of TQM. So we need to think about and how to achieve customer first. To do that, so we should see about we should watch about the threats of a new entrant and so on. So if you need, so redefine relationship among the suppliers and the buyers relationships. And also incorporate data-related process into your system development process. So Now, so there's a lot of to-do lists, but from our experience, based on the total quality management, so the core code of conduct is customer first, and sharing our knowledge is a key to achieve the customer first product or services. Okay. Thank you very much for your attention, and I'm really sorry for the problems about the display. Thank you very much.